Okay, so now we're on to video 2 of week 6, talking about flooding. So, a flood in general, really high level, is it's too much water where it shouldn't be. More technical definition of that is it's the overflowing of the normal confines of a stream or other body of water, or where we have an accumulation of water over areas that are not normally submerged. Few key details why flooding is important. It's actually a top cause of weather related property damage in the US. And in the US, floods kill more people each year than tornadoes, hurricanes, or lightning. So it's a particularly hazardous phenomenon. If we talk about the general types of floods, it's good to get an understanding of what different types of floods there are. Flash floods, those are localized, short duration floods that can occur rapidly and can sometimes happen with little to no warning. Sometimes, though, we can predict them reasonably well ahead of time. It all depends on the particular circumstance. Mostly, this occurs with smaller rivers and streams where there just isn't the volume to contain the amount of water when a lot of water collects in a particular region, so it has to go somewhere else, and that's over the normal bounds of where that river or stream should be. Typical cause of these flash floods, where we get localized short duration but severe flooding, is slow moving thunderstorms that drop a lot of rain in very localized locations, or where a dam or a levee breaks, where water that's held up in one location is no longer held up there anymore and is released where it should not be. Next up is widespread flooding. This is where we consider a flood that occurs when there's either a large amount of rain or over a watershed, a whole river basin, widespread area for many days at a time, where there isn't enough time for the water to return out of its normal channels, which means that there's significant portions of the watershed are inundated for long periods of time. These have slower rises and falls, so they're much more predictable in behavior than flash floods are. The other thing that widespread floods, we'll get into in a little bit. This is an example. So, going view of the Missouri River from a 1993 flood. Again, it's a broad part of a river basin that's flooded due to large amounts of precip or sometimes large amounts of snowmelt over a broader watershed river basin. So we go to coastal floods. That's sort of, we talk about where there's bodies of water, which means where the water can exceed its normal bounds in that body. The coast, the ocean, a big place where that happens. So coastal flooding refers to the inundation of land areas along the coast. Pretty simple definition of flood along the coast. Common causes: higher than average high tide. So combination effect that can go into that, where just normal cycles of the tides, sometimes it exceeds that, but typically you're going to see one of these other things with it, where there's just heavy rainfall in the area, so more water that isn't taken out from the coastal region as usual. Onshore winds, where you just basically get dynamic forcing of the water being pushed farther onto shore and up to higher levels than it normally is. And a big one for coastal flooding is storm surge. And this is a phenomena associated with tropical cyclones based on both the large amount of wind over a sustained period of time, basically building up higher depths of water and pushing them on shore, combined with even a little bit of dynamic pressure effects where there's less atmospheric pressure, which means that more water can return into those areas. So, moving on from those general types of flooding, where we talk about their extent or the regions they impact, now we sort of go into what can lead to flooding. Sort of almost working backwards through the other order, bouncing around a little bit. Landfalling tropical cyclones is a big thing we'll talk about first, and this is where you'll see a lot of news events about these kind of events where you get tropical cyclones that make landfall, resulting from, you get storm surge, you get rise in ocean levels above usual high tide levels due to the strong winds and low pressure from an oncoming tropical storm or hurricane. They also, landfalling tropical cyclones bring with them oftentimes a lot of extreme rainfall. So not only are you forcing ocean water farther, into the coast, you're also dumping a lot more water onto an area. For example, Hurricane Harvey, just a couple years ago. Big example of this where you had combined really extreme rainfall that caused lots of flooding and lots of impacts to people. Moving on, next up, we have training multicellular storms. So if you recall back to our severe weather chapter, one of the types of storms we talked about is multicellular systems. And when they're training, what that means is that they're popping up, they're over a particular where there's a trigger or a lift mechanism, it's popping up and it's moving off, but there keeps on being new cells developing so that there's these cycling and of new cells just coming one after another over a singular area. And that allows, with all these individual cells just continuing to go over an area and keep on dumping rain and precipitation, that can cause flash flooding and probably can be looked upon as the most common cause of flash floods over the central US in particular. And these don't tend to occur. Okay, the key thing is that these are slow moving systems. So the system stays put, even if these individual cells may be fast moving because of the continued development. It's a lot of rain over a particular location for a sustained period of time. When the thunderstorm systems are moving quickly, so derecho is our example of that, a lot of supercells tend to move quickly, it's a lot less likely to cause flooding or flash flooding in this fashion because there just isn't enough time over particular locations for these systems to dump all of that rainfall. Of course, you can, if you have repeated exposure to supercells or you have a lot of rain beforehand and then a last bit of a deluge from a supercell coming through, that can still cause flash flooding, but on its own, fast-moving storms really don't tend to cause these types of flash flooding hazards, again, on their own. But when you have training multicellular systems, where you have continued development, they definitely do. So another common weather pattern is frontal overrunning, and this tends to be associated with widespread floods. So instead of sort of the thunderstorm view we took the last time where it was localized and you just had continued development over the same region, this is where you have a synoptic scale setup that just won't move, where you have a stationary front or really slow moving warm front, where you have synoptic scale precipitation, so broad regions of precip, and a strong, steady flow of warm, moist air going over the front. So that creates continuous or near continuous rain showers, thunderstorms, and areas of precipitation. So you just keep on getting warm, moist air that keeps on producing this precipitation as it overruns the front, which can make a lot of water in a particular watershed, which can then build up and cause widespread flooding. Another common weather pattern is snowmelt. And depending on the rates at which this happens, it can contribute to both either widespread flooding or flash flooding. And this tends to affect, like in the US especially, northern plains and in mountainous regions. It's when thick snowpack melts relatively or extremely quickly. Again, if I say sort of relatively quickly over a broad area, tends to lead to those sort of widespread flooding hazards, especially if combined with other precipitation in the area. If it's extremely quick melting of snow, that's where you can get in smaller localized areas on a shorter time scale, which is flash flooding. The key here with snowmelt is that not only is it a lot of water that just all of a sudden becomes available from solid being stored up in mountainous regions or in cold regions, all of a sudden becoming liquid and having to go somewhere. It also can be made a lot worse is because when the soil is still mostly frozen when you have snowmelt in springtime, the water can't soak much into the soil, so it has to run off and it has to go into rivers and lakes, so you get surface flooding. The other thing is that the rivers themselves are sometimes still frozen over. So you still have ice in them. And when you have a lot of ice moving, it can tend to build up against natural or man made hazards, jamming, and basically creating a temporary dam that builds up water and causes flooding in the area where it overflowed, the river or stream would overflow its banks because of that ice jam. Sort of three areas, if you want to talk about that are particular concern for flooding. One is urban and suburban areas. The main reason is because pavement and concrete, which is prevalent in these areas, creates an impervious surface. So the water can't absorb down into the ground because you have pavement or concrete. So it has to go across the surface until it reaches some kind of man-made storm drainage system. But these storm drainage systems may be poorly designed, or they can get overfilled just because of the amount of precipitation, or they can get clogged by other natural debris. And so that can really contribute to flooding hazards in areas where there already are dense populations, so it's a particular area of concern. Another thing worth mentioning is burn areas where there's been wildfire impact. Here, wildfires can damage the soil and vegetation to the sense where rainfall that normally in a healthy forest would be absorbed into the soil, it now runs off because your vegetation is dead and your soil doesn't have the same properties anymore to be able to absorb it quickly. The other thing is that that soil can also be picked up by the water easier. So you get debris flow where, again, sediment and debris are taken up into the floodwaters. And that can cause even further damages downstream wherever this water flows, because not only is it just water, but there's a lot of dirt and there's a lot of debris in this water that can cause extra damages or can pile up and cause various types of jamming. The other last place to mention is deserts, is that deserts where you don't normally get precip, if they do get precip, they can get a lot at once. And that creates a particular problem because the natural climate of the area isn't conducive to soils that absorb this rainfall. So it tends to run off in gullies and arroyos. And when you get broad scale weather patterns like monsoon flow, which just means warm, moist, tropical air masses coming in to this area, that can create a lot of localized heavy precip, which can lead to flooding in areas that don't normally see a lot of water. So, last up section on forecasting and safety. The National Weather Service issues watches and warnings for floods and flash floods, following the typical kind of rule we talked about with severe thunderstorms, is that watches means that it's expected in the future, the conditions are right for it to happen, but it isn't actively occurring yet. Whereas warnings is that flooding or flash flooding is imminent or happening right now, and you need to take action at that point. Other thing worth mentioning here is that river gauges are a really important tool for monitoring flood stages, and they're also tracked in what they're used for validation when we talk about for forecasting for floods. And the data is showed on a plot like this as a hydrograph. So if you live near a river area or somewhere that's particularly of concern for flooding, this might be a good figure to know how to read and how to interpret, where you have time along the x-axis here, you have the stage or the depth relative to some reference level for your particular river or stream, and you can track over time where it was measured in reference to where flooding would be. So this is actually South Skunk River near Ames, and it's actually going into a major flood stage right above where record is. This is back from 2008. And so you can see how it's been observed to climb up here where they anticipate it being, and how it is expected to decay back from right here in major flood stage back down to typical levels. So safety. Last point I have two slides here on safety for flooding. Biggest safety tip when it comes to floods is when you're driving is turn around, don't drown. Most flood fatalities in the US are from people driving into flood roadways, and it's entirely something that can be avoided if you just turn around and find alternate routes or head back and don't travel via car. And a point about this is as little as 6 inches of water can sweep away most vehicles off of a roadway. So even if you think that you can clear it with the base of your vehicle, there's still enough momentum in the moving water that it can sweep away off your tires from a loss of traction. And even given that, if you can see that there's less than 6 inches of water across the roadway, you expect, based on where you knew the roadway to be, that there's less than 6 inches of depth. Even then, you usually can't see if the roadway is all the way consistent and still there beneath the floodwaters, because floodwaters are often murky. They have soil caught up in them and sediment, because the amount of water can wash away roads. It can cause sinkholes, as you can sort of see from this car in a parking lot over here. And even at that being said, even if you can see the road underneath the floodwaters, you still can't tell if the road or the ground is actually have enough structural integrity to hold up across the time when your vehicle is going to, you want to cross this roadway. Maybe you can get lucky, but it's a very dangerous thing. And because this is where most flood fatalities happen, it's not worth it. Turn around, don't drown. And I just, on that last point, I have a little demonstration video of something I just saw across Twitter a day or two ago that I just wanted to play for you as a demo of this.
Up here. This is incredibly scary. Okay, we're backing up.
So, roadway entirely clear, but flooding happening underneath.
Same road that we were just standing on seconds ago. So thank God that we are backing
compromise the structural integrity.
Slowly going off of the bridge. We are slowly backing back as first responders continue to come towards this area to get it together. Back to you all. Washed up here.
So yeah, big thing. Big thing. Don't mess around with floods and roadways. So other safety tips: if you live near a flood-prone river area, so near a levee or a dam, or if you're in a low-lying river basin, need to be extra alert during spring snowmelt and when there's heavy precip in the area or anywhere upstream of you. And things like this, you need to be prepared to evacuate, because sometimes that's the best safety measure that can happen when there's widespread expected flooding, is to just get out and stay safe. Another thing is that a lot of times construction and there's sandbagging or construction of temporary levees to help keep, for an expected flood stage, to keep things more contained. And so being able to volunteer to help construct those, very good thing to do for a safety of both yourself and your community members. Other things that if you're in travel over urban area, avoid places like this that are low-lying roads near rivers or near streams, because those tend to be where it floods, especially because you have concrete impervious surfaces, so there's really nowhere for the water to go if it overflows the stream or the river. If you're outdoors, avoid camping or having any kind of recreation along riverbanks or streams whenever there's thunderstorms, because without warning, if there's a deluge of water and precip upstream from you, water can come down unexpectedly quickly and you can be in a bad place. You can be swept away by said onrush of water, so it's best to avoid said spots whenever there's a risk of heavy precip. When it comes to tropical cyclones, and we'll be talking a lot more about tropical cyclones in the next video focused on that topic, but the key thing for those is when there's evacuation orders or recommendations, be sure to follow those. Follow the recommendation of the authorities to keep yourself and your people in your care safe. And again, because storm surge and flooding is something you don't want to be messing around with. And so with that wraps up our safety tips for flooding. There's lots of really great resources for this online if you're interested in more, so feel free to look at those. Otherwise, last video this week is going to be on tropical cyclones coming up next. Thank you.